Hello everyone, today we are taking a look at Unit 0, Lesson 6, Parallel and Perpendicular Lines. So we've been looking at lines and their different characteristics, in particular the slopes of lines, the y-intercepts of lines. Now we're going to talk about two specific types of lines and how we know whether or not two lines would be parallel, whether or not they'd be perpendicular, and what does that really even mean. Okay, so we're going to start with parallel lines. So remember that parallel lines are lines that never cross. Or you might hear they never intersect. Okay, if we were to draw a pair of parallel lines on a graph, like just a rough sketch, they could be angled anyway, but they're running right next to each other at a similar steepness. So because they're running at the exact same steepness, they're never going to cross each other. So parallel lines are going to have the same slope, and they're going to have different y-intercepts. Okay, so we'll take a look at some examples. We'll graph one together, and then I'll get you to pause the video and graph the other set on your own. But we'll talk about kind of what's similar about these equations that we can tell is why they would be parallel lines. So we'll call this first equation equation 1, and this equation 2. Okay, so for equation 1, we can identify those characteristics we need in order to graph. We can identify our slope. So our slope is 4, or 4 over 1, we'll write it so it's easier to graph. And our y-intercept is -5. So you always want to start at that y-intercept. Our y-intercept is -5, so we're going to plot that point, 1, 2, 3, 4, 5. And then we'll use our slope to plot the next points after that. So from our y-intercept, we're going to go up 4, 1, 2, 3, 4, and over 1. And then again, 1, 2, 3, 4, and over 1. Okay, and then we will draw a straight line. Okay, there's our straight line. And then let's take a look at, we'll label that. So that's line 1. Okay, and then I'm just going to actually change colors so we can see that this will be line 2. So again, my slope on this is also 4 over 1, but my y-intercept is now 2. Okay, so we'll start by plotting our y-intercept at 2. And then from there, we'll plot the next point. So we'll go up 4, 1, 2, 3, 4, over 1, up 4, 2, 3, 4, over 1. Okay, and then we'll get a nice straight edge ruler again, and we will draw our straight line. Just trying to line up my ruler. There we go. Okay, so that is line number 2. Okay, so hopefully when we look at these lines, we notice a couple things, right? We have equation 1, we have equation 2. They're running at the same steepness. So you can see that their slopes are the same, so they're never going to cross. So these are our parallel lines. Right? They're never crossing. They're always running at the same steepness. Their slope is exactly the same. Okay. We should see a set of parallel lines with our next set of equations as well. So let's just number them. We have 1 and we have 2. Okay, I'm going to get you to pause the video and try to graph these, but before you do, I just want to point out one thing, and it's where that negative sign is. So notice here we have the negative on our 2, so that's saying that our rise is a -2. Here you see the negative just kind of next to the fraction. Okay, you can apply it where you'd like. I would always advise you to apply it to the top number. It just makes graphing a lot easier, but those mean the exact same thing when you're graphing your slope. Okay, so take a second to pause the video, graph those lines, and see if you can recognize that they're parallel. Okay, so those lines are up now based on their y-intercept and based on their slope. We can see that equation 1 and equation 2 are looking like they're parallel as well. So let's just note that these are also parallel lines, right? And just to highlight that key point one more time, the reason these are parallel is because the slope is the same. Same slope. Both slopes are -2/3. Okay? We're going to take a look at another graph now that we will do together, but these are a little bit different. We don't have the same slopes in these situations. So we'll look at equation 1, we will look at equation 2. Let's start with equation 1 though. So in equation 1, we have slope, that's 4. Again, I'm going to write it as 4 over 1. And we have a y-intercept at -5. Okay, same as that equation from above. So we'll start by plotting our y-intercept, 1, 2, 3, 4, 5. And then our slope tells us to go up 4 over 1, up 4, over 1. Okay, and I'm just going to grab my ruler. And we're going to want to draw a nice straight line so that we can recognize how these different qualities kind of change the look of the graph. So 1, 2. Just want to get my ruler just right. That looks good. Okay. Okay, so that's equation 1. Let's take a look at equation 2. So we have a slope that's a -1/4, and we have our y-intercept at 2. So now recognize our slopes are not the same. They do look like they have some similar qualities, which we're going to talk about in a minute, but they're not the same. They're not the same value. So right now our y-intercept is at 2. Okay, and it says for our slope, we're going to go down 1 over 4. So down 1 over 1, 2, 3, 4. And then down 1 over 1, 2, 3, 4. So again, I want to get my ruler and line it up so it lines up well with those 3 dots. Always making sure you're using a straight edge because you want that line to be nice and straight, especially once we start talking about things like points of intersection, right? If we're not drawing a straight line, it's kind of really hard to tell where the graphs are going to intersect each other. Okay, so that is equation 2. All right, so let's take a look at these slopes and see if what can we tell about them. How are they similar? Okay, so my slope for equation 1 was 4 over 1. My slope for equation 2 was a -1/4. Hopefully we can see that these kind of just look like flipped versions of each other in this case, right? 4 over 1, 1 over 4, but then they also had a negative sign on them. So when we flip a fraction, I just want to right here. So a flipped fraction going from 4 over 1 to 1 over 4. A flipped fraction, and I'm going to put an example in here. Okay, so a flipped fraction is called a reciprocal. I'm just going to write that in big letters because it's almost a vocabulary word for this unit, okay? It's important to understand what a reciprocal is. So whenever we flip a fraction, we're taking the reciprocal of that fraction. So that's what we have here. We have basically taken the reciprocal fraction from the first equation. And when we do that and make it negative, we've taken the negative reciprocal, okay? What happens is we end up having 2 lines that meet at a right angle, okay? 2 lines that meet at a right angle are called perpendicular. So those 2 lines are perpendicular to each other. And I just want to write here, whenever you see a symbol, we have a mathematics symbol that tells us that something is perpendicular. It looks like an upside down T, like that. Okay, because that looks like 2 lines meeting at a right angle. So perpendicular lines are lines that meet at a right angle. Okay, if the lines are perpendicular, then what do we know about their slopes? That's what we were just kind of learning about with that vocabulary word. Okay, their slopes are negative reciprocals. Okay, we take the slope of one line, we flip it, and we switch the sign on it, so it's a negative reciprocal. And just to go back up to that parallel note, I want to give you this mathematics symbol for parallel lines too. So whenever you see 2 lines slanted like that, that means that they're parallel to each other, okay? So there's a mathematics symbol for parallel, there's a mathematics similar symbol for perpendicular, okay? I'd like you to try to graph those next 2 equations. So again, we'll call this equation 1, we'll call this equation 2, and hopefully again, we'll be able to notice what's going on with our slopes there. It looks like, I'm going to erase this in a minute, but you have a negative 2/3. If we flip it and switch the sign, we're taking the negative reciprocal. So those two lines should meet at a 90-degree angle, which would make them reciprocal, which would make them perpendicular rather. Okay, so pause the video and try to graph those two lines. So having a look at these two equations, when they're graphed on the line, you can see that again, yes, they intersect at a right angle, or they're perpendicular to each other. Okay, so those are the things to keep in mind as we work through the rest of the note. Parallel lines are going to have the same slope. The lines are not going to cross. They're going to have different y-intercepts. Perpendicular lines are going to have slopes that are negative reciprocals of each other, and they're going to intersect at a right angle. Okay, so the next part says to state the slope for the given equation. Then write the slope of a line that is perpendicular to it. Okay, so remembering that slopes that are perpendicular will have negative reciprocals. Okay, so the slope of this line here that we have, y equals 3x minus 4, we can say the slope is 3, or 3 over 1. So then the slope of and I'm going to write that perpendicular symbol. So we could write it like this, m perpendicular, like with a subscript of that perpendicular symbol. So I'm going to flip 3 over 1 to 1 over 3, and I'm going to change the sign on it. So it's going to be a negative 1/3. Okay, so we'll try one more together, and you guys try that last one. So the slope of this line is a negative 1/2. So the slope of a perpendicular line is going to be 2, and we could write it as over 1. We don't need to, and we're going to switch the sign, so it's just going to be a positive 2. Okay, pause the video, try that last one on your own. Okay, so there's the result of the perpendicular line slope. Okay, so 17/11s will flip to 11 over 17 and make it negative. So this next chart, we're going to see if we can identify, which we should be able to identify, the slope and the y-intercept of a particular equation. And then also, what would the slope be of a parallel line to that equation, and what would the slope be to a perpendicular line of that equation? So we'll try the first example together. So we have, just so we all remember, y equals mx plus b, right? And we know m is our slope, and we know b is our y-intercept. So our slope for this equation is going to be 5, or 5 over 1, however you would like to write it. Our y-intercept is going to be a positive 1. Okay, so a line that has that is parallel to this line would have the same slope. So it's going to have a slope of 5. A perpendicular line slope, we're going to flip 5. So instead of 5 over 1, it's going to become 1 over 5. And we're going to change the sign on it. All right. Pause the video and see if you can fill out that next row on your own. Okay, there's the solutions for that next one. Slope and y-intercept we should be able to identify at this point. A line that's parallel will have the same slope, and a line that's perpendicular will have a slope that is the negative reciprocal. Okay, we'll take a look at that next one, just some things to kind of keep in mind. This is y equals 1/2 x, and even though it's not here, it's basically a plus 0, right? So we can assume that that's a plus 0 being implied there since it's not written. So our slope for this one is 1/2. Our y-intercept is 0. Again, a parallel line slope is going to be 1/2. And then the perpendicular line, the slope of that is we're going to take 1/2, we're going to flip it. So it's going to be 2 over 1, or just 2, and we'll change the sign to a negative 2. Okay, the next two lines, we're going to have to kind of work backwards to get our equation and to get our parallel slope and our perpendicular slope. So for that first one, they've given us our slope, they've given us our y-intercept, so we should be able to write the equation as y equals 8x minus 4. A line that is parallel is going to have the same slope. A line that is perpendicular, we're going to take the reciprocal of that slope and change the sign on it. Okay, this last row, again, we're going to have to work a bit backwards to get our slope. So if we have a perpendicular slope is 2/3, well then what's my regular slope? I know that perpendicular lines have negative reciprocal slopes. So the slope of my original line must be 3/2 instead of 2/3. and it's going to have a different sign on it. It's going to have to be a -3/2. Now we have our slope, we have our y-intercept. We can write our equation as y equals a -3/2 x plus 5. And the line that's parallel to that is going to have the same slope as well. So a -3/2. Okay. Now they're going to give us some we're going to see if we can figure out the equation of the line based on some information that's given to us in a question, knowing what we know about parallel lines and what we know about perpendicular lines. Okay, so it says, determine the equation of a line that is parallel to y equals 3x minus 7. So what we should be thinking when we see parallel is we should say, okay, so same slope. If it's a parallel line, it's the same slope, and it has the same y-intercept as this other equation. So same y-intercept means it's going to have this as your y-intercept, because that's our y-intercept. And if it's a parallel line, it has the same slope. Okay, so it's telling us our slope is 3 and our y-intercept is a +1. So we can easily write that equation as y equals 3x plus 1. Okay, the next equation is saying to us, remember, whenever we're trying to write the equation of a line, we need at least, and I'm going to write that up here, we need at least 2 pieces of information. Okay, and those 2 pieces of information can be our slope, our y-intercept, or a point, right? We need all that. Any 2 of those pieces we will be able to work through figuring out the equation. Okay, so it's perpendicular. This next one is perpendicular. So we know that the slopes are negative reciprocal slopes. Okay, so perpendicular to y equals 1/2 x minus 7, and it passes through the point. So we have a point here. We'll say the point is our xy in our equation. All right, if 1/2 is our slope, then the slope of this new line is going to be a -2/1, right? We're going to have to flip it, and we're going to have to change the sign on it. And then we also have a point at -3, 0. All right, so if we were to substitute that information into our equation, y equals mx plus b, we know y is 0, m is a -2, x is a -3, and we're going to have to work to find our y-intercept. Okay, so a -2 times -3 is 6 plus b. That means b is going to equal a -6. So now we have our slope, we have our y-intercept, so we should be able to write our equation. Y equals -2x minus 6. All right, I want to work through this next one together, and then I want you guys to try the last one on your own. So it says it's parallel to y equals 3. So first of all, this tells us the same, some stuff. If it's parallel, it means it's the same slope. And when we look at y equals 3, we should be thinking that's a very special type of line, right? Y equals 3 tells us we have a horizontal line. Well, if it's parallel to that horizontal line, we know what the slope of a horizontal line is, right? Horizontal line has a slope of 0, all right? So there's just a couple different ways we can do this. We can just look at what the point is that it passes through and figure out what the equation would be, or we could actually plug it into the y equals mx plus b and work through it that way as well. Okay, so it's parallel to y equals 3, and it passes through that point, -2, 1, okay? So -2, 1, remember, equation for a horizontal line is going to be y equals some b value. And when we're given a point on the line, we know that those points are a, b. So really we could just say, okay, the equation of this line is y equals 1. But that's a lot of kind of reasoning through the whole process. And if you're a person who likes to maybe follow the steps regardless of any of the special cases, let's do that as well. So let's say or, okay? In this case, we can take y equals mx plus b, and we can plug in all of our information we have. So we know that my y value is 1, my slope is 0, my x value is -2, and we're trying to find our b value, okay? So 0 times -2 is just 0, so 1 equals b. So we could write this as y equals, our slope is again 0x plus 1, or we could just write y equals 1. So it's a little bit longer, but it's just a little bit different reasoning, right? And finally, the last thing we could always do is draw a picture that might help us understand it as well. So our first equation was a horizontal line at y equals 3. So if I just had 1, 2, 3, we had a horizontal line of y equals 3. It says we have a parallel line that passes through the point -2, so 1, 2, and then up 1. So we can draw that horizontal line there like that, and you can see all of the y values, hopefully, would be 1 for that line. So we would have an equation here of y equals 1. So lots of different ways to kind of figure out what that line would be. Okay, the last example for the note today, I'd like you to pause the video and try that one on your own to come up with the equation. Okay, so there's the equation for that last example. Take a look at that. Our slope is going to be a negative reciprocal of the slope from the original equation. So our slope from our original equation is 4. So the negative reciprocal would be a -1/4. And then we plug that in along with the point that we were provided to find our y-intercept. And once we have our y-intercept and our slope, we can write our equation as y equals -1/4 x minus 4. That's all for your note for today.